All right, good morning, everyone. Today we are going to continue our review for the IA on Friday. So this is a problem that you should totally be able to do based on Unit 4 and Unit 5. And this is fair game for the IA as well as the AP exam. So let's go ahead and get started. An automobile company wants to learn about customer satisfaction among the owners of 5 specific car models. Large sales volumes have been recorded for 3 of the models, but the other 2 models were recently introduced, so their sale volumes are smaller. The number of new cars sold in the last 6 months for each of the models is shown in the table below. Okay, so please make sure you're taking notes because, again, just like yesterday, you'll need to submit an image of your notes as your credit for your exit ticket. So looking at this table here, I see, okay, so I have a number for each car model, A through E, and then it gives me the total number of cars sold. So it says the company can obtain a list of all individuals who purchased new cars in the last 6 months for each of the 5 models shown in the table. The company wants to sample 2,000 of these owners. So for part A, for a simple random sample of 2,000 new car owners, what is the expected number of owners of Model E and the standard deviation of the number of owners of Model E? Okay, so there's a lot of stuff going on here. I see that I have this table and they're asking me for the expected number and the standard deviation for just Model E. So the only thing that I'm focused on here is Model E, and I need to figure out how am I going to determine the expected number, so essentially our expected value, and the standard deviation. So I need to think of, okay, what type of variable am I looking at? Because I don't calculate the expected value and the standard deviation the same way for every type of random variable. So I see that I have a table here. Usually when I see tables, the first thing I think of is a discrete random variable. I know that in a discrete random variable, I have to have a probability distribution. For my table. Well, if I look at the table that they've given me, I don't see any probabilities. So this won't be a discrete random variable. Okay, so I have to think of the other variables that I know. Well, there's a normal random variable, but it doesn't say the word normal here, so I can't assume normality. So I wouldn't use a normal random variable. Our next ones are a binomial and geometric. So I know for a binomial, I need to fit my criteria, my bins, for binary independence, number of trials, and probability of success. So we're only focusing on Model E here. So our binary is going to be Model E or not. So maybe something else, A, B, C, or D. For independence here, we know that for testing for independence, we just have to see, okay, are we taking a large sample here, but not too large? Well, if I do 2,000, my sample, over the population, my total here, 3, 5, 4, that's definitely going to be, let's scoot this over, that's definitely going to be less than or equal to 10%. So we're good to go with independence here. So we've met the first 2 criteria, so we're looking good thus far. The N here, note that this is not normality, this is number of trials. So this is going to be 2,000 since that's our sample size. And then for success here, okay, so we're just looking at Model E. So essentially, I need to find the probability of getting a Model E car. Well, we can just take the values in the table above. So our probability here is going to be equal to the number of Model E cars divided by the total. So 2,323 over our total, 297,354. So that is going to be equal to a very, very small number. So let's calculate that really quickly. That's going to be 0.0078. All right, well, this is looking like a binomial random variable. So for the expected value and the standard deviation, let's take a look at our AP reference sheet to refresh how do we find those values. So I don't need it on this page. On this page here, it says if x has a binomial distribution with parameters n and p, which we've determined n and p, then this is going to be our expected value, and this is going to be the formula for the standard deviation. So, going here for part A, our expected value is going to be equal to our n times our p, so 2,000 times 0.0078, and if we crunch that out as well, we will get approximately 15.62. And then for the standard deviation, we would say the square root of n times p times 1 minus p. So that is going to be the square root of 2,000 times 0.0078 times 1 minus 0.0078. And that is going to be equal to 3.94. Okay, so we've completed part A here. So part B, when selecting a simple random sample of 2,000 new car owners, how likely is it that fewer than 12 owners of Model E will be included in the sample? Justify your answer. Okay, well, since we've already determined that this is a binomial random variable, we're going to find probability, just like how we always do for a binomial random variable, either using binom CDF or binom PDF. So it's saying how likely it is that fewer than 12 car owners. So that is, we're trying to find the probability that x is less than 12. So here, I know that if I have an inequality, I need to use a CDF here. So I'm looking at looking at my notes, I know that for a binom CDF, I have to have less than or equal to. So I need this to be something probability x is less than or equal to a value. So in order to do that, we can think, okay, if I am strictly less than 12 here, that means that I'm less than or equal to 11. So that's what I'm trying to find the probability of, essentially. So again, since this is an inequality and we got it into the form of less than or equal to, we can now use binom CDF. And our parameters are n, p, and x. So in this case here, our n is 2,000. Our p is the 0.0078. And our x value is inside here, so this is 11. So we're going to go through these steps again because it's been a while since we've calculated a binomial random variable. So if we go to our calculator here, we go to second vars to pull up the distribution menu. That's very important. We're looking at a distribution, and we want to look at the binomial CDF distribution. So I click on that. And then it pulls up here, and so for those of you who have a TI-83, this will look similar to yours. TI-84, it'll give you the menu to type in your numbers for each. So we start with N, so again, alphabetical order, our 2000, our probability 0.0078, and then our X value, 11. And if I hit enter, then that'll give me my probability. So 0.147 or 14.7%. So the probability would be 14.7%, and that's it. All right, so for part C, this one is a little bit just more conceptual, not really mathematical computations are needed. So part C, the company is concerned that a simple random sample of 2,000 owners would indicate fewer than 12 owners of Model D or fewer than 12 owners of Model E. Briefly describe a sampling method for randomly selecting 2,000 owners that will ensure at least 12 owners will be selected for each of the 5 car models. Okay, so part C is saying, okay, pick a different sampling method other than a simple random sample to ensure that we get at least 12 from every single group. So we can list out the type of sampling methods that we know that are not an SRS. So clustering, stratifying, and systematic. Okay, so just thinking about what each of these mean, I know that in a cluster, I split them into groups, and then I know that I'm sampling a whole group. So I split them into groups, and I sample whole group. So maybe I pick 2 groups or 3 groups to do. So let's say, for example, I only do model A and model B. Well, the concern is that we won't have 12 owners selected for model D and E. So if I pick clustering, there's not a guarantee that I'm going to get 12 owners from every single group. So I wouldn't want to use a cluster sample. Let's look at our stratified. So stratified, we also split into groups. But here I take a proportion from each group. So let's think, is that going to guarantee that I'm going to get at least 12 from every single group? Well, if I split them into groups, so A, B, C, D, and E, which they already are, if I take a proportion from every single group, well, yeah, that's going to represent every single group. So I think I'm going to want to do stratified here. But let's just look at systematic just to ensure that I'm not wrong. So let's look at what systematic is. So let's say we take every nth owner. Well, if I line up the 200 plus thousand people and I take, let's say, every 10th person, is that going to guarantee that I'm going to get at least 12 from every single group? No, that's not really going to guarantee. It could happen, but there's no guarantee that it will. So here I'm going to want to do a stratified sample. So let's actually go ahead and just answer the questions so that we are answering the question. So again, it's saying, briefly describe a sampling method for randomly selecting 2,000 owners that will ensure at least 12 owners will be selected from each of the 5 car models. Okay, so we know that our goal is to have 2,000 as our sample. So we need to have a way in which we get 2,000. So let's just say, in order to have an equal representation of each car model, we should take a stratified sample from each model. Okay, so we've stated what we're going to do, but we need to describe how are we going to get the 2,000 here. Well, we need to take an equal proportion of every single car model. So we found the expected value for model type E, which was approximately 16 cars. If we round to the nearest whole number here, we would get 16. So let's say we need to make sure that these proportions are equal throughout, because stratifying, sometimes we take an even number from every single group, but sometimes we want to do an equal proportion from every single group. So similar to how we did the chi-square test for goodness of fit, sometimes we split up the total evenly, but sometimes our expected value was based on the percentages given. So we're going to do that here. We're going to find the percentages from every single value here, and then we're going to do that. So I'm going to have to keep flipping back and forth here just to make sure I have these correct. So this is, again, kind of just scratch work on the side. It's not really going to go into my work. So for model A, we have 112,000. Go back. Okay. 338 over our total of 297,354. And then once we find this proportion, we want to multiply it by our 2,000, and that's going to give us our expected value for A. So let's just go ahead and crunch this out here. So that's going to give me approximately 755. So for model B, if I crunch that out, that was 96174 over my total. And again, once I find that proportion, I want to multiply it by my 2,000 to find the expected value here. So that's going to be 647. For model C, we have 83,241 over our total. And again, we want to multiply that by our 2,000, so that's going to give us approximately 560. So for model D, this had a lot smaller value, just 3,278 divided by our total. And again, we multiply that by our random, our simple random sample, so that's going to give us 22. And we already know for E, we calculated that, and that was approximately 16. So here, if I go back, these are the numbers that I want to take. I want to take 755 people from model A and 647 from B, and so on. So that's what I want to say. So for example, take a random sample of 755 owners of model A, 647 owners of model B, 560 owners model C, 22 owners of model D, and 16 owners So that is our solution for part C. Okay, so again, make sure that you have this in your notes and you're submitting this to the exit ticket file on Google Classroom along with the CFUs for the day, which will be in the Zoom call. So please make sure you're joining the Zoom call to get those CFUs and then submit that along with your notes to the exit ticket and then complete the classwork that's similar to today's FRQ. All right, have a great rest of your day, everyone.